Good evening, everyone. I'm Amy Sangiolo, Vice Chair of the Newton Democratic City Committee and Chair of the Climate Crisis Subcommittee. I'd like to welcome everyone to another one of our panels about the climate crisis. Whether because of the increased incidence of extreme weather, rising or warming seas, the energy crisis caused by Russia's invasion of the Ukraine, or any of 1,000 other reasons, people everywhere are recognizing that society has to change its relationship to fossil fuels. But what are the best ways of doing this? What is already being done? These are some of the questions we hope to address in our panel discussions on the climate crisis. We'll provide you with the information you need to understand solutions being considered or implemented so that you can choose to get involved either as a voter, as an activist, or as a consumer. Tonight, we're focusing on natural gas, which supplies 32% of America's overall energy budget annually, while producing 34% of energy-related emissions of carbon dioxide. Burning natural gas produces less carbon dioxide per unit of energy than coal, fuel oil, or gasoline, but if released directly into the atmosphere, it has 80 times the warming potential of carbon dioxide for 20 years. Innovations in mining methods introduced earlier this century allowed the U.S. to become the world's top gas producer. Conversions of many coal-fired power plants to natural gas have helped reduce power sector greenhouse gas emissions 32% from 2005 levels. Nonetheless, the extra potency of gas in driving global warming and the recent UN IPCC finding that the world is not on track to limit warming to 2 degrees Celsius increases the urgency of the need to use much less gas in the immediate future. Tonight, we have an impressive panel of experts to discuss the current status and future of natural gas in addressing U.S. energy needs. Before we begin, I want to mention that there is a change to the published program. Unfortunately, Ezra Hausman is recovering from a recent medical procedure and is unable to participate. Ezra will be fine, but tonight, Dr. Dean Murphy, who is principal at the Brattle Group, will be taking his place on the panel. Dr. Melissa Chan, Director of Grid Solutions and Strategic Partnerships at Fermata Energy, is our moderator this evening. Melissa, the floor is yours.
Thank you, Amy. And to quickly introduce our 3 panelists, I realize I actually don't need to read your full names because you are all labeled, at least on my screen. Starting with in alphabetical order by first name, Adam has worked at a utility and in venture capital. We have a variety of viewpoints and backgrounds on this panel, but I think we all do agree about phasing out gas. Adam in particular brings years of experience in infrastructure and transaction design for clean electricity, biofuels, waste to energy, and water. Dean has a longer look at things. He's an engineer turned economist who works on long-term planning and forecasting studies that examine the transition to decarbonization in the heating and electricity sectors. And Jay is a member of Newton's Citizens Commission on Energy, and his day job is evaluating many new and established companies in the climate tech industry. So before we get started, I'm going to let you know that I am going to cut you off. If anyone goes on for more than 3 minutes, I am rewatching. I will try to be polite about it. I don't know how this will work over Zoom, but I'll probably start talking at the same time as you, and we will see how Zoom, I guess, picks who wins that. I guess the alternative is I can try one of these little gestures here and see if that works. I'd like to also invite the audience to submit questions or comments via the chat. I'll be watching that, and we'll read off questions to the panelists. I hope that this can be a interactive session this evening. So, panelists, thank you for coming this evening. I hope that we can have a fun, lively conversation about gas. This is all something that all 4 of us work on in some way, shape, or form as we think about energy, whether it's immediate infrastructure development or longer term planning. And so in this last year, we've really seen the effects of many different things affecting gas commodity prices, between weather and an invasion on the other side of the world. And it's really opened the eyes of people who manage our wholesale electricity markets, the utilities, regulators, and ordinary people who have shown up for this conversation tonight. And so at some point, you've probably had conversations with people about gas bills, or switching to electric cars or electric heat. And this summer, the New England Conference of Public Utility Commissioners actually held an emergency meeting about the price of gas. And given New England, we want to move towards a renewable future, but we know it takes a long time to develop grid scale renewables and battery storage. I'm going to pose this question actually first to Adam. I'm wondering what your advice would have been this summer if you were invited to that meeting, about how could we, within just 6 months, try to meet our needs for electricity and power in New England.
Wow. If I had a perfect answer to that, I probably would have been invited to that conference. So right now, natural gas generates approximately 60% of the electricity used in Massachusetts. I say approximately because it's it's not, we import electrons from other states. ISO New England is a fairly integrated regional grid. But more or less, that 60 to 65% is a good walking around number. And that's for electricity produced by natural gas. So if you switch over to an electric vehicle and you plug in and charge at night, 65% of that is on a statewide basis. And I understand Newton has a particular energy choice program that Jay probably knows more about than I do. But at the moment, switching to electricity does have a substantial gas usage. So if I'm a utility commissioner, and as a utility commissioner, I have two jobs. I have to deliver consistent electricity to my ratepayers. I have to manage the cost to those ratepayers, and I have to deliver a regulated return on investment to my shareholders if I'm an IOU, as National Grid is. So I'm looking to, and in Massachusetts, you have to comply with environmental regulations. The latest Massachusetts Renewable Portfolio Standard, which was in 2021 passed by the legislature, signed by Governor Baker, is 40% renewables by 2030. And that's measured by consumption, unlike some other states, which is measured by generation. Melissa, I'm bumping up on your 3 minutes. However, my suggestion at that utility conference would have been to encourage residential conversion from natural gas to electricity. It would have been to continue, and I know this is not necessarily aligned with some of the environmental white papers out there. However, it would have been to continue to repair methane leakage on the pipeline network. It would have been to invest in renewable natural gas, which, full disclaimer, my company's invested in, which is today not non-existent in Massachusetts. So not conflicted there. We've got nothing in Massachusetts. It would be to comply with the generation utility requirements to continue deploying renewable electricity at the grid level. There's virtually no coal or oil in Massachusetts today. Massachusetts energy comes from hydro, non-hydro renewables, wind, solar, and gas. I'll stop talking, but that would have been.
I was going to ask Dean, actually, given what Adam has shared about the need to integrate more resources, thoughts on infrastructure development, I'm curious your thoughts in regard to the assumptions that we can make on the speed of developing infrastructure, and your thoughts on what may be, I realize this is a loaded term to say to an economist, but cost-effective investments for state or cities and municipalities to consider.
Well, a couple of points. One, we shouldn't be thinking about things that we should do in the next 6 months or next year. We need to take a long view. We need to understand where we need to be in 2050 or maybe 2040, and put ourselves on a path that's going to get there, which is not necessarily the path that follows the greatest reductions in the shortest amount of time. Now, early reductions are really good because it reduces cumulative greenhouse gases in the atmosphere. But you need to set yourself on a path that's going to get to the long-term goal that you need. And infrastructure takes a long time. And because it does, focusing on what you can do in the very short term really isn't going to allow you to change your infrastructure very much. One of the big issues with gas, of course, is most of the buildings that are going to be around in 2050 are already here. And they're already here with usually gas, sometimes oil or propane heating systems that are not all that easily converted to electricity. So we need to have a plan to do that. And I think we need to do that in a sort of a managed, programmatic way, rather than an approach that says, well, we'll just offer subsidies to consumers and we'll see who decides to convert. I think we need a much more intentional conversion of infrastructure to move away from gas enough to meet our climate goals, which doesn't mean we will necessarily move entirely away from gas, although it could. But even I understand that National Grid has their corporate decarbonization goals. They plan to reduce their gas throughput by half and substitute renewable natural gas and hydrogen for the remaining half. One big part of the reason that you have to do that is because there's not enough renewable natural gas to satisfy anything close to our current demands. And even 50% is potentially pushing the availability, certainly at reasonable prices. So I think you need to take a long view. Electrification has its own issues, and I won't have time to get into all of that here. Hopefully we can touch on some of that a little bit later in the program. But I think we need to really look to the long term and ask ourselves, what kind of a gas system will we have in 2040, 2050? It will certainly move a lot less gas. It may be a much less extensive system in that parts of it could be pared back.
I actually want to touch on a term that you mentioned, and I'm not sure who would be the right person to answer this question, but for folks on the line who have not heard about renewable natural gas yet, do we have a volunteer who could explain what that is?
I can give you my take. It's renewable natural gas is methane. Just like fossil natural gas is methane, it's the same chemical. It's just produced, rather than removing it from the ground from old gas and oil deposits that were laid down 100 million years ago or so. It's produced often by fermentation of organic waste or other processes that produce methane in similar ways to fossil gas, except that we're doing it now. The reason it's renewable is typically the raw materials that are used to produce it are usually plant matter that has drawn the carbon dioxide from the atmosphere probably within the last few years. If you then convert it to methane, which gets burned and released as carbon dioxide, you're just kind of round tripping carbon dioxide from and back to the atmosphere. You're not making a net contribution in the same way you are if you're pulling carbon out of the ground that's been there for 100 million years and then releasing that into the atmosphere.
The only things I would add to that is the vast majority of RNG today is coming from landfills. And it's projects that take methane that otherwise would have either been flared at a landfill or just gone into the atmosphere as methane, gets instead effectively welled out and into a gas upgrader and then used for renewable power or renewable gas. Dean is absolutely right. Even in theory, if you were to put RNG projects on every landfill, on every wastewater treatment facility, and wastewater sludge is also a big source of methane. on every dairy farm where cow manure produces methane, you still would not be able to get enough get renewable gas that we anywhere close than natural gas that we as a country or a globe consume today. And so it is very much part of the solution mix. I think I agree with just about everything Dean said. But it's there still needs to be tremendous reductions in overall gas usage, whether renewable or fossil.
There's actually a question that came in over the chat. How do we get rid of gas? How do we get the word out about the current lowest cost energy supplies, solar, wind, and storage electric plants? And then there's a 20-minute video, which we will not watch together, but I suggest folks in chat perhaps bookmark that for later. This brings me actually to Jay. I happen to know what your day job is. So I'm curious your opinion, Jay. You know, there is wind, solar, and storage electric plants. I know about your work, you know, thinking about the balance of supply and demand, and curious if you could weigh in here on how do we perhaps not just get rid of gas, but change our demand for it.
Change our demand for gas or our demand for energy in general?
Both, actually, because we learned from Adam that 65% of our power is coming from gas.
Yeah, I mean, that's true. You know, I don't really know how I think we've been doing energy efficiency for years. And I mean, there certainly are heat pumps and other, you know, more, you know, popular developments these days that can help with the total reduction of usage. But I mean, I think at some level, I mean, to kind of have a modern industrialized society, there's only so much demand that you can get rid of on a overall basis. I mean, you know, Melissa, what you were hinting at is, you know, I work in demand response. So, I mean, for those that aren't aware, that's basically kind of, you know, programs run through either the ISOs like ISO New England, or also by distribution utilities like Eversource and National Grid, that reward customers for reducing usage when the grid is most congested or is in a peak condition. And you know, what my company does is, we're an aggregator. You know, we work with customers, mostly commercial and industrial, that are able to participate, and you know, in return, we guide them through the programs, and they again, you know, are compensated for their participation, and so forth. So I mean, I think the key is not really so much reducing overall demand, though certainly, again, ongoing efforts in energy efficiency are certainly helpful, but more kind of shaping that demand. I mean, we see in Texas, you know, and other wind-heavy states, you know, negative power prices at night. You know, it's going to increasingly become the case, you know, with more solar penetration, you know, during high, you know, periods of peak sunshine. So the fact that we're ending up with negative energy prices kind of shows there's still this disconnect between the price signal and the actual usage. I think, Melissa, a big step in that direction is the move toward AMI metering in Massachusetts, which, you know, I applaud our DPU for finally pushing that forward. Obviously, I wish in some respects we'd done it much sooner as a state. On the other hand, I've heard the counter argument is, by waiting so long, the AMI technology's gotten much better, and so there's more you can do with it in terms of sort of decomposing that load, you know, really kind of understanding what specific loads are running within a building. So I think, you know, with the you know, deployment of AMI meters, which will certainly take time in Massachusetts, that will hopefully open up the way for more price responsive you know, rates that incentivize, you know, customers to use power when renewables are producing in higher amounts, use less power when that's not the case. There will always be the need for storage, you know, demand response, and other technologies that can kind of help smooth out that load over, you know, over time. But I think, you know, getting to a place where customers are, you know, more closely aligned with the price signals of the market, I think will help a lot there.
Excellent. I'm curious about panelists' view, and I will bring this back to Dean, because I'm assuming your work at the Brattle Group, you've looked at a lot of time of use rates and incentive design. And we'll start with you because I am wondering if you could speak to how do utilities use AMI infrastructure in order to incentivize customers to use electricity at different times, just as Jay is suggesting there's negative pricing. I don't see negative prices on my electric bill, but they're out there.
No, you don't see negative prices on your electric bill. You could if you had real-time pricing, and some large commercial industrial customers can access real-time pricing. Residential customers, by and large, can't or don't. So you're not likely to see negative prices, and you're not likely to see real-time prices. You may well see time of use prices where the utility will say, typically prices are, electricity is more available at some times than others, so we'll make the price cheaper during the times when it is more available, in general, and more expensive at times like, 7 or 8 p.m. after the sun has gone down and people are getting home and using more electricity. That's a typical peak load time and peak price time. And one of the challenges that you see with a lot of these programs is the price differential isn't necessarily very big. It might be 20% or 50% more expensive to use power during the peak times than the off-peak times. And people will respond to that to an extent. Certainly, there's a segment of our population that will respond actively to that. And they may be as much environmentally motivated as they are monetarily motivated. Most people, and I confess this includes me, don't think very much about their electricity price when they're using electricity. And I do think one of the things that we need to do, I'm sure Jay is much more familiar with this than I am, is we need to make it to engage systems that make it very easy for people to do this without thinking about it, so that their appliances will automatically default to running at off-peak times. Electric vehicles are going to be a very important component as they start to become more common, partly because they just take so much electricity to charge them. And you can pretty much charge them anytime you're not driving them if you're in a place where you can plug in. So rather than plugging your car in and starting the charging at 7 o'clock at night when everybody else is using electricity for lots of other things, if you can plug it in and your car is smart enough and your connection with your utility is smart enough to say, well, let the car sit there, it's not going anywhere until 3 a.m. and charge it at 3 a.m. You can shift a lot of load that way. I do think that transportation electric vehicles are going to be one of the ways that we solve this problem of matching the hour-to-hour fluctuations in renewable power production and consumption. Just because that particular application, A, uses a lot of electricity, and B, it can be very flexible if it's enabled with the proper systems, which can include price discounts, but wouldn't even necessarily need a lot of that.
Yes, I'm going to bring a question back to Jay to build upon Dean's answer. There's a question in the chat that's still focused on pricing signals, but getting to what about a carbon signal? Perhaps, Jay, have you seen that in the markets that you're working in? By markets, I'm talking about the wholesale markets that are providing power that is then delivered to the rest of us by the local utility.
Yeah, I mean, I don't really actually have that much of an opinion on a fossil fuel carbon fee. I mean, oh, seems like Adam does. Why don't I just yield
Switch to Adam. Thank you, Adam.
Oh, Jay, I didn't mean to cut you off. Yeah, no, in the chat, it's a great question. A national or even international price on carbon is a fantastic idea. And all the smartest economists and industry folks agree with that. Unfortunately, it's politically impossible. In 2009, the Markey-Waxman bill tried to pass something like that, and it didn't get anywhere. And the Inflation Reduction Act, at a federal level at least, is the climate legislation that we have for the next 10 years. At a federal policy level, which we spend a lot of time on, that was the big kahuna, and that is a very big deal, and it's transformational for the U.S. energy economy. But that, to make a crude analogy, for the federal environmental climate lobby, the Inflation Reduction Act is, was the dog that caught the car. That's it. There's no legislative appetite to do anything beyond that for the next several years. So a fossil fuel carbon fee is great. And like many great economic ideas, it unfortunately won't happen.
What a carbon fee on this is, I'm curious about biofuels, because aren't they carbon based as well? Would that affect biofuels in the same way as fossil based natural gas?
Biofuels, they have their own set of incentives and direct tax credits and cash payments from the federal government. There's the RIN system under the Federal Renewable Fuel Standards, or RFS, which is something like a cap and trade system for fuels. It's somewhat limited, and it's tremendous subsidy to Midwestern corn and soy farmers. I don't say that as a positive or negative statement. I'm just stating a fact. It is what it is. So Melissa, it's a great point. The U.S. Renewable Fuels Program is something like a cap and trade just for fuels. It basically mandates billions of gallons per year of different kinds of fuels, gasoline, diesel, come from renewable sources. And you can debate whether corn ethanol is or isn't renewable. But that really isn't a fee, because that's just a government payment to producers. It's not any kind of a tax.
Okay, yeah, so perhaps there might be a carbon tax on it still, since there's carbon in it. This is bringing my mind to hydrogen, actually, and I realized as we were talking about gas, and hydrogen is sometimes seen as a substitute for gas in several ways. And let's put this question out to the panel, and whoever wants to take it first. Your thoughts on hydrogen? Does it matter, brown, green, or blue hydrogen? Brown being from natural gas, blue from water, if I understand. Of course, correct me if I'm off here, and green being generated from renewable power. Dean.
I'll have a crack at that. Yes, it matters very much what kind of hydrogen, and hydrogen is all the same, it's all hydrogen, but it matters very much how it was produced. Most hydrogen now is what's called gray hydrogen. It's produced from natural gas. It's by stripping the hydrogen off of the carbon, combining the carbon with oxygen from the air and releasing that into the air. And then using the hydrogen usually for chemical or petroleum refining processes, also to produce ammonia for fertilizer. So the current gray hydrogen is as problematic as burning gas, and usually it is burning gas effectively. Green hydrogen uses electricity to split water into its components, hydrogen and oxygen. And if the electricity is renewable, then the hydrogen can be carbon-free. I think there is definitely a major role for hydrogen in the future, probably not the very near-term future. It's a longer-term play. I do believe that hydrogen will be limited to very high-value uses, like industrial processes that are hard to decarbonize in other ways, potentially for creating fuel for air travel, shipping, where it's difficult to electrify. A number of people are talking about blending hydrogen into the natural gas system. And if it's green hydrogen or blue hydrogen, which is kind of like gray hydrogen, except you don't release the CO2 to the air, you sequester it underground. If you mix hydrogen into the gas system, that can reduce the carbon intensity of the gas system. I am a little bit skeptical about that, in part because of price and availability. It also creates some technical problems in that hydrogen doesn't always work well with existing gas systems, particularly older gas systems. Hydrogen tends to leak more readily than methane. It can cause problems with steel pipes. And so much of the gas system would need to be upgraded or replaced in order to make it compatible with high levels of hydrogen.
So what do we do with our existing gas infrastructure, right? If we are going to leave gas and it might not be repurposed for hydrogen or I guess lighter gas, because if the gas that we use is primarily, or I guess more proportion to hydrogen and less carbon, and be lighter and just a different content, what do we do with all this infrastructure that we have spent money on? Utilities have invested in it with what we've paid them. Any thoughts from the panel as to what do we do with this infrastructure?
Can I offer a quick reaction? Then I really want to hear what Adam has to say. I think we are going to rely quite heavily on it for the next 20 to 30 years, no matter what, no matter which pathway we go on. If we go on a pathway that says we're going to shut down the gas system, we're still going to rely on it for several decades, and we're going to need it. So we need to make sure that it is safe and reliable. The big question is that sort of long-term future. What does it look like? Do we have a gas system that is essentially as extensive as our current gas system is, or does it get pared back a little or a lot? And I'd love to hear Adam's thought on this.
It gets pared back, and over time, a lot. I think most folks agree, even in government, we're not, so at a basic level, we're not putting new gas lines in the ground. That activity has largely ceased in Massachusetts. We are maintaining existing lines, and those do need to be maintained, at least in the near term. But over time, and this is where, if there's a clear policy recommendation here, we're not going to get rid of gas companies tomorrow or next year or even in 5 years. I'm not even going to say if that's a good or a bad thing. It's not going to happen.
It would be a bad thing, I'm sure.
Okay. Or at least politically, I won't even take a view on that.
Yeah.
But just practically speaking, it's not going to happen. There's far too much gas usage. So electrify everything tomorrow is just not a real political statement. I do think, and I think this aligns with the Massachusetts Renewable Portfolio Standard, which is law, to say that let's cut it by 40–50% over the next 10 years or by 2030 is still incredibly ambitious. I can see Dean already saying, well, Adam, even that's impossible. But and if that is a policy objective, and really curtail residential use, curtail areas where you really concentrate gas usage for power generation, and those high value industrial commercial uses that are harder to replace with electricity, and then concentrate that pipeline network only where you have to have it and supplement with renewables, to me, that's a legitimate policy statement. As opposed to, well, we just need to get rid of gas.
Got some great comments in the chat, but before we get to those, Jay, you've got something to add to this.
Yeah, I agree with what's been said so far. I think that is the realistic view. And Melissa, to your ultimate question of what happens with that distribution network, I think ultimately, but I agree with the other panelists that it's, decades down the road, it does become obsolete. And sure, there were investments made that, then are sort of worthless. But I think long term, we should consider it a win that eventually we'll just need one distribution system for electricity rather than maintaining the sort of redundant distribution networks that we have today to cover both electric and gas.
A great point. So the comments in the chat, and I appreciate this quote that someone has put in the chat. I don't know who we can attribute it to. When you find yourself in a hole, first thing to do is stop digging, as in we replace gas with electric. And we have a great factoid in the chat that gas lines are being replaced for $800 million a year, the total cost to be $40 billion. But that money could be used for electrification, and this is specifically for Massachusetts. So there's recognition, of course, that this infrastructure is very expensive. And then there are two questions, both from Josh. And Josh, I'm going to read your first question first, which got a little bit buried. Are the panelists aware whether there will be penalties to the gas companies if they don't lower their production and emissions on the schedule legislated in Massachusetts for 2030 and 2050?
The general answer is yes. Now it gets a little bit detailed in terms of whether we're talking about generation, distribution, or consumption. The Massachusetts RPS is consumption driven, and the compliance methodology for RPS in Massachusetts, at least, is with the REC, or Renewable Energy Credit Program. So if a gas company doesn't comply, and RECs are on the electric side, but if an obligated party is not either complying with the regulations or purchasing enough RECs to offset their overages, then yes, they are in violation. That said, and I don't want to give it too long an answer. When we think about policy and we talk about years 2030 to 2050, the policy is going to change a lot. The utilities have a living, breathing relationship with their regulators. And there's administrative legal interpretations involved. There's litigation involved. So the direct answer, John, is yes, there are penalties. How exactly those get expressed and what specific behavior those penalties incentivizes gets very complicated, and Dean probably has a view on that as well.
Yeah, this gets to a comment that Paula provided a little while ago, carbon tax and dividend cash back checks. And it seems like there could be different, levers to push here. And I wonder, Dean, if you might speak to different ways the policy makers and regulators can work with the utilities to incentivize what we want to see them do.
What Adam was talking about, I believe, was in terms of the penalties for not meeting climate goals. I believe that was for the electric sector and not meeting the renewable portfolio standard. To my knowledge, and you would know better than I do, Adam, there's not anything corresponding to that on the gas side. We haven't really figured out what we're going to do with gas. The Massachusetts Future of Gas docket at the Public Utilities Commission is sort of on hold at the moment without any decision. So I'm not aware of any penalties for the gas companies for not meeting the reduced emissions requirements. In fact, we haven't even settled on what those emissions requirements are. The larger question that you posed, Melissa, about a carbon tax and dividend, as an economist, I can tell you that economists love a carbon tax, and politically returning that to our population as a dividend rather than the government keeping it as a tax seems like it would make it more palatable. But as Adam suggested a little while ago, it has gone nowhere. And I don't actually think it's going to go anywhere. And I've almost given up on it as a fruitful policy lever. I think it would be great if we could have one, because it would push things in the right direction. And we need all the help that we can get to transform our energy systems. So don't get me wrong, but I don't think, and we certainly shouldn't put our faith and reliance in a carbon tax, because I don't think it'll happen. Probably not at a meaningful level in any case. So it's a lovely idea. As an economist, I love it, but I'm not holding my breath.
Yes, probably let Adam, do you have something to add?
Dean, you're right. There is no direct requirement on gas companies to incorporate renewables. My response was that the power companies and the gas companies exist in an integrated ecosystem, and the renewable requirements on the power companies do spill over to the gas companies. I should have clarified.
Right.
Maybe spillover is a poor choice of words.
Yes, but they are the same, and they are still procuring a lot of gas to generate our power. Just going back to our conversation on gas distribution networks, there is a question in the chat. Someone would like to get the panelists' views on networked geothermal long-term infrastructure, and this may get to how can we repurpose our existing gas infrastructure.
I mean, I can go first. I haven't talked in a while. I mean, I don't really have professional insight into this, but just as an observer, I think all the geothermal pilots that are going on are really interesting. And I think geothermal can work really well in certain scenarios, say like a brand new development that's built or something like that. I know I personally struggle to see how it could ever truly scale. I think, getting, wholesale, portions, territories to move on to that technology, as well as sort of having the labor force needed to do that, kind of in a orchestrated manner. I just don't personally see how it scales beyond pilots, even though I'd love to see that happen. Definitely curious if either Adam or Dean have ideas of how it could scale, beyond the current level.
I think there's some chance that it could scale in particular locations where the density is right, and the positive and the negative needs for energy can help to balance one another out. I share a lot of your skepticism, Jay. We're not going to get to the point where the majority of Massachusetts is heated using network geothermal. The majority of Massachusetts just isn't. It's either too dense or not dense enough, I think. So there's a sweet spot in there where it may be useful. You alluded, Jay, to the challenges of putting it into an existing, like down an existing street. Well, then you need almost everybody to sign up. Right. In order to make the economics work, and that is a significant challenge. I think there's sometimes a misconception that this is a way to reuse gas infrastructure, and to my knowledge, you can't reuse the gas pipes to carry essentially water in one of these systems. You could reuse the right-of-way, or also use the right-of-way. But typically you'd have to put in the network geothermal before you remove the gas, because otherwise somebody's going to be quite cold in the interim. So it's a potential way it's similar in some ways to the gas system in that you're moving energy through pipes underground, but I don't think it directly reuses the natural gas infrastructure. Adam, you may know more about this.
Very curious about your thoughts here.
No, I don't disagree with anything that was said.
All right. I figured we would all be in agreement about many things, and this is one of them. There are some, again, great comments in the chat, and there's another YouTube clip that somebody has shared with regard to the 13-minute TED Talk on carbon dividends. There's also a comment that Canada has a substantive carbon tax, and curious if anybody here is knowledgeable about that and what perhaps are the conditions in Canada that make this possible compared to the US.
We've done projects in Canada that do take in the OBPS and take that into account. We're currently building a landfill diversion project in Rhode Island that's going to sell RNG to Irving Oil up in New Brunswick for them to comply with their Canadian fuel standards. Canada without, and by the way, this is a really knowledgeable group on the audience and putting great stuff in the chat. Canada, they go back and forth a fair amount depending on whether there's liberal or conservative governments in Ottawa. For the past several years, there's been a liberal one, and that's great in terms of policy. I think just from the investment perspective, there's always some cautious skepticism around, well, all that's going to go away, the next time the government turns over. The U.S., believe it or not, actually has a little bit more stability in policy, at least when it comes to climate, in terms of when things like solar and wind credits get past the federal level, they typically do not go away.
So getting to the cost and the expensiveness of, say, building a networked geothermal network, I don't know how many times I could say network in that comment, but I managed to say it many more times than I thought I would. It will take time to develop this infrastructure. And so I think a consideration for all of us as we're trying to think about reaching goals and the cost associated with them, what considerations do you think need to be accounted for to ensure a just transition? And perhaps, Adam, you might be close to this because I know you've had some experience reviewing applications for federal funding under the Obama administration. That, how do we ensure that low and moderate income and environmental justice neighborhoods have access to these new technologies at the same rate and levels as wealthier and well-funded parts of the state?
I mean, it's something we give a lot of thought to. We, just by virtue of building projects on landfills and brownfields and wastewater plants, we've done a lot in low-income communities in terms of job creation and environmental impact. So I say this as a big proponent, both commercially and policy-wise, of expanding renewables in an equitable way. I think that really is, the theme of this panel was what can Newton folks and people be doing, and at that local level, whether it's state programs, I mean, it's no secret that's where government plays a role in helping middle and lower income people access whether it's goods or services that might be otherwise be priced out. So things like incentives for residential equipment, things like mass save, those are all things to support. And it's and I say this as a Newton Public Schools parent, the word equity means a lot of different things to a lot of different people. The way to lift all boats is through development, and it's through access, and it's really supply side solutions. And as someone who spent their career both building in low income communities and building renewable assets, I'll leave with this comment that might be a little conversation provoking, and we're all neighbors here. I have some trouble with the notion that we're in a climate crisis, but we can't get solar panels from China, and we have to make sure that everything we do is complete, checks 100 different scorecards on equity and justice, and we can't do this and we can't do that. Okay, without making a political statement, someone can certainly believe all those things. That's fine, but then don't say it's a crisis, okay? Because if we're in a crisis, we're importing solar panels from China, okay? We're building renewable resources wherever they are best for the grid. And I'll close there. And again, I say that to provoke thought and conversation, understanding some people might disagree with it. But Melissa, just trying to directly answer your question.
Yes, I feel like that would have been a spicier open to our conversation.
And that's a personal statement, not a company or Newton statement.
Jay, your
Yeah,
thoughts?
I'm excited to jump in here. I mean, Adam, I agree with a couple of your themes. There were things I was going to bring up. So I don't know how many saw this, but just this week, I think it was, Sonova was a recipient of one of the DOE loan program offices loan guarantees, which they're planning to use to lower their cost of capital and therefore be able to get more solar loans out to low-income homeowners who otherwise, would be, stuck with very high interest rate, basically untenable solar loans. So, I mean, I think kind of to Adam's point, government involvement is really helpful here, whether it's just, as simple as a loan guarantee that sort of, de-risks, the loans that get the technology into the hands of lower income people, incentives and so forth. And I mean, to Adam's point also, I totally agree. I mean, I think you have to be doing this stuff universally. I think a great thing about the incentives in the IRA is that, with sort of a tiered system, right, where, there's incentives for everyone. There's just higher incentives for those that are low income. I think that's really important. One thing that I've had some exposure to here in Newton that's been disappointing is, with all the funding coming out for electric school buses, cities like Newton are kind of excluded from a lot of at least the first round of federal funding on that because we're not an environmental justice community. And I mean, I think it's certainly important, again, to give larger incentives to, EJ communities. But I think, these things should be tiered in such a way that, they can become realistic, for all communities. And I guess, Adam, touching on that final point you brought up about China, I do struggle with this. I mean, I in some ways love the domestic content, aspect of the EV credit, in the IRA. But that said, I think it should be phased in more. I mean, to Adam's point, I think what we've all seen it does is, create a scenario where there's very few models that are currently eligible for the full credit. I think that's a mistake. If this is to Adam's point, if this is a climate crisis, which I do believe it is, then we should be doing everything to get more EVs out there. That said, we're already seeing where the domestic content requirement is stimulating more manufacturing to happen in America. And I think we've kind of seen over the last couple of years, whether you want to look at, geopolitics or just supply chains, how much of a mistake it is, to rely so much on China or to rely on any other foreign country. So I think that we should be putting in those types of caveats. But to Adam's point, I think they need to be more phased in. They need to be sort of taking into account the reality of, does this slow down the effort?
I agree with all of that. If I can add just a little bit of perspective. Adam is absolutely right that, if this is a crisis, why aren't we pulling out all the stops? And I think the answer is it's a different kind of crisis from most of the crises we're used to dealing with. Crisis usually means something that needs to be dealt with in the short term. And as we were discussing a little while ago, this is a long-term problem. Jay, you said there are good reasons for not wanting to rely on international supply chains for things, and I absolutely agree with that. So I also agree that it would be a good idea to phase some of these things in a little more gradually, just because we don't need to create disruptions in the supply chains for electric vehicles and solar panels in these things. The supply chains are having enough trouble right now as it is. But I think the fact that this is a long-term crisis, not a short-term crisis, doesn't make it any less impactful. In fact, it may be more important. But it does mean that what really matters is the long-term path and being able to get to that long-term goal, more than whether we can import Chinese solar panels in the next 6 months.
Yes, we're all in agreement, but I think to the point of, while it is a crisis and we do want to get this infrastructure out everywhere, rich or poor, there's a few points that are raised in the chat, which I think are great to have the counterpoint. And so, the point that Bob is making is, those who are lacking the capital to electrify could be left behind, or they're left, paying off legacy infrastructure, what's currently going into the ground. And then somebody else raises the point, would it be viable actually to say we're not going to pay, we're going to strand assets for new gas infrastructure built after 2024?
I just want to ask a question to some of the questions in the chat about, are we going to pay for these assets? Any one of us can get off gas right now, and I'm sure many people have that are on the Zoom. And no, you don't have to pay for those assets. You can call National Grid, say, please turn off my service if you haven't already, and you can go all electric. I know the theme is, how do we convince everyone else to do that, which is a good question. But to the direct question of how do we get off gas, you can do it today. It's not a problem. I mean, it's, there's cost, but you can.
However, at a broader, for the individual, at the individual level, that's absolutely true. At a broader level, if we were to say to National Grid, any new investments you make after 2024, you're just not going to recover those. We put ourselves into a very difficult position because National Grid wouldn't make those investments and the system would not continue to be safe and reliable for the next couple of decades that we really need it to, we need to rely on it. We might be relying on a smaller system over time, but it needs to be maintained. We don't necessarily need to expand it. We may not need to replace all parts of it, but we do need to keep it safe and reliable in the meantime. Just telling the gas company you can't earn anything on anything you do after 2024. Now you may put some standards that says things need to meet these standards in order to be able to earn a return, or in order to be guaranteed to earn a return. But it's not just as simple as telling the gas company you can't earn anything on your new investments, because it takes a lot of money to keep the system going, just to keep it operating.
To work on phasing this out, and we've talked, several of us, over the course of the conversation about decades to phase out, but what could it look like? And maybe, Dean, we would start with you, and then Jake, so you just pull yourself off mute. But what does it look like if we decide, you know what, we're really going to seriously do this, and we're going to have the strategy? If you could architect what this was, and we were certain that we could commit to it and stick to it, and not have, as Adam points out, changes with administrations, like, could stick to it, and this is the plan. What might this look like?
Well, interestingly, I think electrification will play a big role one way or the other. And whether we electrify everything or electrify just half of things, we have a lot of work to do in the next decade or so, even to get halfway. And so we can start on that without deciding whether we're going to shut off the gas system entirely or not. It would make a lot of sense. When I say that, I mean it would save a lot of money if that could be a coordinated effort between the gas and the electric system, so that if we're going to pare back parts of the gas system, we pare back the parts that are in imminent need of replacement, so that we just say we won't replace that pipe, we will convert everybody that's served by that pipe to electricity. And that can happen in a small way at first, but it needs to be coordinated. If we electrify in an uncoordinated way, you could electrify 80% of the Commonwealth and not be able to shut down a single gas line, because the other 20% of people are scattered thinly around on all of the gas lines, and somebody needs service from every line. So I think a coordinated way to transition people off of gas, starting in the parts of the system where it saves the most money, would be a good way to start.
Yeah, so I agree with what Dean said. And one thing I would add on, I was listening to a podcast earlier today from Canary Media about the electrician shortage. So I mean, Dean, you mentioned, oh, if that gas line, is in disrepair, just convert everyone there to electric, and that's great. But right now, if you try to call and get an electrician to come to your house, there might be a few week delay, optimistically speaking, to get that to happen. Not to mention also supply chain delays for the equipment itself. So I mean, I think the number one step, if we're really talking about pulling out all the stops, is, and I mean, I preface this saying I'm not a policy person by training, so I can have these good ideas, but I don't know how you actually, execute it. But we need to get more electricians. What does that mean? Does it mean, some sort of GI bill that pays for people's electrical training, or some sort of tax break to, further subsidize or pump up the earnings of electricians? Like I said, I don't have those answers. But I mean, to me, you need to have more electricians if we're going to have any realistic shot of speeding up that timeline. The other piece I would add, again, to what Dean said, that I certainly agree with about the coordinated aspect, and I mean, here I really put on the hat of my day job, is we need to have more opportunities for behind the meter assets to really participate in energy markets. And I mean, that could mean multiple things. Dean mentioned earlier kind of the concept of managed charging for EVs. I mean, certainly if we electrify everything, we need to have smart EV charging. We need to have smart hot water heaters. We need to have all the devices kind of orchestrated in a way that we don't just spike demand in ways that we can't handle. And then at the same time, we need to have an incentive structure in place, whether that is through wholesale market programs or is just through the utility rates, to basically make it so that people are kept whole financially as they go through this transition, which is a very expensive transition. Whether you're charging people out of pocket or you're doing incentives, which, hey, is then with taxpayer money, one way or another, it's expensive. So we need to make it worth people's while.
So based on how we pay for our energy, whether it's gas or electric, and it may be coming from the same utility or not, like, how do we, I guess, how do you think we can measure those trade-offs that utilities are making between investing in gas versus electric, and pacing these two things or setting the pricing? And I realize like there's just a lot of issues wrapped into each other between pricing for these two commodities, payments in order to pay off infrastructure that we've invested in, payments to maintain it so that it's safe while we're phasing it out. They're hard, and I actually don't envy the utilities for having to figure this out with the regulators. But what might we be able to figure out there in those trade-offs?
Well, it's difficult for utilities to trade off between electric and gas, because the electric and gas systems are mostly operated independently now. In some states, I don't know if it's true in Massachusetts, electric and gas companies are prevented from coordinating because that would be considered a type of market power, because gas and electricity can compete to provide energy services. And there was a time when it seemed like a good idea to encourage that competition in order to keep prices low for customers. Even my understanding, and Adam, you'll know better, is that the sort of day-to-day coordination between gas and electric companies pretty much doesn't happen. Each of them sees their own demand and works to meet it, and they're not coordinating. I do think that needs to change.
Yeah, I think that's definitely true on the LSE or load serving entity side. Yes. On the generation side,
yes, of course,
a little bit more independent, meaning independent from regulation. So there's some more common ownership, but I do agree with that. And by the way, just going back, what Jay said about training more people, I 1,000% agree with. Ultimately, there The solutions here are supply side solutions. There needs to be more clean electricity created. There needs to be more ability to deploy that. I mean, I think that's a great idea, a GI Bill for folks like this. Melissa, and getting back to the theme of why folks have joined this webinar, what can we do to get off gas, the title of this. I think at the same time that Dean and I are saying, this is long term, we're not going to go all electric tomorrow or next year or in 2 years. The reality is there is infrastructure that requires a lot of money to just maintain. Politically, there's still, and public service commissions are fundamentally political entities. That they're appointed by politicians. They can be pressured, as a lot of the environmental groups are doing, to say, well, what are your long-term plans for becoming carbon neutral or emissions free? How over the next 15 years or 20 years are you gas utility, converting your long-term capital plans? The National Grid document, the Plan 2070, that got a lot of criticism for justified criticism for saying, oh, well, we can just do, we can be all clean hydrogen and that'll be that. I'm simplifying a lot, but National Grid only bothered publishing that as a result of pressure to become carbon neutral. Without that pressure, even that wouldn't have happened, and that shifts the conversation. So I think again this realistic policy notion of not how do you eliminate gas tomorrow, but how do you eliminate half of natural gas in Massachusetts over the next 10 years, or something to that effect, is direct local grassroots political volume that folks can realistically deploy.
So to the extent of activism or grassroots campaigns, what would be a way to align expectations from people who are raising their voices and hoping for more from their utilities and policymakers? Like, what is a way to balance expectations on one side and what is feasibly possible, like physically possible, with engineering and the amount of schooling and training and apprenticeship programs we're going to need in order to build this future?
I think the state has a lot of public interaction resources. The Mass DOER, the governor's office has an energy, section. There's a lot of touch points. Go to public meetings. You'd be surprised. The Mass DOER and both Governor Baker and now Governor Healy, they'll have webinars, they'll have meetings, they'll have public comment sections, and you can sign up and you can get to know the folks in those offices that are, Melissa, to your point, the intersection of regulation, policy, and reality that are actually managing things. And I think and time is always the tough. We all have jobs, but for folks that are passionate, that have the time, there's absolutely ways to make the right connections to make your voice heard.
Ian, did you have something to add?
Yeah, I agree with Adam. I think that this needs to be done at a social level, not an individual level. We're not going to solve the climate problem by people individually choosing to electrify their homes. We really need to do it socially, and that comes through government and regulation. And I know that those are nasty terms, even in Massachusetts. People don't like to be told what to do. But I think we do need to coordinate this at a social level, because it's difficult for me, as an individual, to say, well, I want to burn renewable gas if I'm going to burn gas. I can only take the gas that comes out of the pipe that runs down my street. I can't choose these things. The other thing is, many people are more likely to go along with these things if they understand that everybody is doing it and everybody is sharing in the cost of it. Why should I be the one to decarbonize? It's going to cost me more, and it's not going to make my home's energy use isn't going to make a significant difference. But if everybody is decarbonizing, then it does make a significant difference. And I'm not the one who's, whistling in the wind. So I think these solutions do have to come through our government. So yes, speak to your representatives and let them know that you care about this and you'll vote on it.
Great. We have a lot of really great Pamela, I'm not sure, I'm not seeing everybody in the audience here, but it's amazing the number of videos that you are posting and how relevant they are to this conversation. There's a question from Gary, our host. And actually, Gary, Dean has mentioned carbon capture and sequestration, but perhaps we can go back to talking about carbon capture and storage. Is this a silver bullet? I think there are trade-offs, right, to developing carbon capture and storage, and this is a fairly new technology, even though there's been a lot of R&D on it for the last 20 to 30 years. It's still pretty new.
I think it may be a useful technology in some instances. It won't solve the gas problem. You can't capture carbon from the fuel that you burn in your furnace in your home. It won't happen. You might do it at the scale of a large power plant or a factory that's stripping hydrogen from methane to make ammonia. So in some instances, it may be a very useful tool. And I'm sure everyone on this call has heard the saying that there is no silver bullet. There may be a lot of silver buckshot. And that's one of the bits of buckshot, I think, that could be brought to bear on this. But there is no silver bullet, not carbon capture nor anything else.
I'm curious about the panelists' opinion regarding the development of ambient air capture. And I realize some of the audience may think we're getting astray here, but I have heard recently on some podcasts that perhaps we are beyond the point of return with respect to climate change and managing our demand and building this infrastructure to wean ourselves or drop natural gas as quickly as possible. We're not going to be able to do it in time. And so we need to try to figure out ways to capture carbon from the ambient air and store it, whether in the ocean or deep underground, or plant more trees and hope the trees will absorb all this carbon. What are the panelists' thoughts on this technology, given how new it is? Hard to test it at a lab scale. We only have one planet. What might we do?
I don't think it's a choice. I don't think we choose to cut our carbon emissions by stopping burning fossil fuel or do direct air capture. I think we do both. Neither one will work by themselves. I think I share the view of Adam and Jay. I think in that it's going to be very, very difficult, and perhaps we will not succeed in cutting our emissions as much and as quickly as we would like. Which makes a case for direct air capture or some other technology to remove carbon from the air. But I don't think we can continue burning fossil fuel like we do and say we'll just solve the problem by capturing it from the air after we emit it.
Any thoughts, Jay?
Nothing to add. I mean, I agree with all of that.
I'm not familiar with that technology, so can't really comment.
I think the answer is no one is familiar with that technology. It doesn't exist yet. It does. It perhaps at best at pilot scale. But
yeah, to be honest, I find the technology kind of terrifying. If we decide to use it, it's a planet level science experiment, and we only really get one chance to get it right. Like, what if we overshoot and go in a complete opposite direction, whatever that means? We can't know.
Well, the good news is there's a lot of excess carbon in the atmosphere. If we start taking out too much, it'll take us a long time to get back to where we should be.
That is quite true. Yeah, we have gone pretty far from what our natural climate is.
I would say in general, and there's some comments in the chat too, that 99% of the utility, industry, finance, brain space, and time is spent on creating renewables and not CCS post-combustion pulling CO2 out. Because those things are still, I agree with Dean, everything should be looked at. If we all think it's a crisis, you can't leave any stone unturned. But the CCS and even more, technologically advanced things like Melissa's talking about are just not really deployed today.
Yes, and towards developing more zero carbon power resources, I did see a comment earlier in the evening regarding what would it take, or how is Massachusetts doing in developing wind resources? Is wind resource like our number one resource for the state, or should we look for something else? What might be holding us up in developing more of this resource?
My first job in the energy industry was developing wind farms for Florida Power and Light almost 20 years ago. I mean, there's a lot of wind. Wind is one of the more widely deployed non-hydro renewables. Wind has trouble scaling. In any given region, once you've picked the top 20 wind sites and build wind farms there, sites numbers 21 to 30 start falling off dramatically as far as viability. You don't have that problem in solar. Solar is a lot less real estate sensitive than wind is. If it's sunny on one side of the street, it's going to be sunny on the other side of the street. And offshore wind is just really, really, really expensive. I mean, to tighten a screw, you have to hire a captain and a boat and maritime insurance and probably deal with the longshoremen union. And so it's getting built. It gets built in Europe. There is a little bit more offshore wind in the U.S. More wind will get built, but wind has I hate to use the word headwinds. Wind has some challenges growing from 4% up to 20% of the grid, even though it looks like it makes a lot of sense.
I mean, there's also the problem of transmission, right? I mean, this kind of gets to the real estate note that Adam brought up. I mean, solar, by virtue of being able to be put on a rooftop, can easily be put where the population center and the load center therefore is. Wind, you have to kind of get it from where it is to where it needs to go. And we seem to not be great overall as a country at building sufficient transmission to move those things around.
We definitely have to get better at that.
Building transmission.
Yeah, but look, a transmission line is a very nasty thing to have in your backyard. It's correlated with higher incidences of cancer. To get transmission from one place to another, you're going to go through low-income areas. So from a policy perspective, the policymakers have to put their cards on the table. Do you want transmission or do you want environmental justice? You can't have both.
Great point.
Yes, I suppose this gets back to Jay's original mention of distributed energy resources and trying to think about how we can, manage our loads at home, as well as possibly develop our own solar or battery resources at a household level. But at this point, panelists, it's 8:20. You've been very generous with your evening. And I'd like to invite you each to give a final statement, and we'll go backwards alphabetically. So we'll start with Jay, and then Dean, and then Adam.
Oh, you're putting me on the spot, not giving me any time.
I am.
Yeah, I mean, I think sort of by its design, this was a panel where we were all pretty agreeable. We weren't the screaming cable news network talking heads, but I think, kind of trying to summarize what I got out of all of this. I mean, I think there's a long path ahead. You know, this is not something that happens overnight. To Dean's point, I think it would be pretty devastating for, you know, modern society if it happened overnight. But I think, you know, we need to look at things kind of from all the different angles, whether that's, you know, how do we, you know, beef up manufacturing, which the IRA has gone a long way towards stimulating that, but more needs to happen. One area we didn't even really get into at all tonight, I'm realizing, is the mining and the, you know, precious metals needed for all these, especially EVs, but also battery storage. You know, all of this electrification comes with its own set of challenges in terms of, you know, building out these technologies. So, you know, I think we need to push on that. We need to push on, you know, providing the skills development needed for the immense workforce that's going to be required to do this. And then, you know, Dean's point, I think, you know, really kind of at the center of all of this is it needs to be a coordinated transition. How do you do that? You know, I mean, that's the part that I really kind of puzzle over. I mean, the other pieces are not easy, but it seems like you can kind of see how we could get there. But I mean, the coordinated transition is going to be hard. So I think we have to really make sure we have all those other pieces in place, make sure we have the manufacturing capacity, the labor force out there, and the right sort of mix of carrots and sticks to get people to do it. And then we have to figure out the way to do it so that, you know, we don't end up with the 80% transitioned and yet still needing 100% of the infrastructure.
Thanks, Jay. Dean?
Yeah, I think we have to realize that this transition is not going to happen without people noticing. It's going to take a concerted effort across our society to do this. It's not going to be impossible. It's not going to destroy our way of life, not remotely. But it will take a concerted effort. I don't like the analogy, but we need to be on something like a war footing, in that we acknowledge that things need to be different, and we're going to put significant resources toward it. We'll get a lot of benefit from it. Our air will be much cleaner when we stop burning fossil fuels, and people will notice that. We're going to create a lot of jobs, and that will be a very good thing. But it's not going to happen on its own. I don't think we're going to be able to offer a subsidy here, an enticement there, and expect everyone to suddenly flock toward these new renewable energies. By and large, they're not cheaper when you're able to externalize the cost of the carbon emissions of fossil. So you have to pay more out of pocket for these renewable technologies than you do for the fossil technologies, by and large, not always. And we have to get okay with that, and as a society say that we as a society will fund this transition. We're not going to put it on each individual person. We're going to, I feel like, Adam, if you electrify your home, you're doing your part to reduce carbon emissions. Why shouldn't I pay for a piece of that? Because you're helping to do what I'm not doing yet, but we all need to do in the end. So there will be cross subsidies, and there have to be, and there should be, because it'll be cheaper and easier and quicker and more effective that way. I'll stop there.
Great points. And Adam, you will wrap this up.
On electrification, I drive 3 gas guzzling cars in my family, and they're all at least 10 years old, because I drive cars into the ground and never buy new cars. And I would argue that's more environmentally friendly in some ways than going EV, but maybe the next car will be an EV. I'd just like to thank everyone for participating. I think all of us really enjoy talking about this topic, or else we wouldn't be here on a Thursday night. And I love to stay in touch and trade YouTube videos with anybody on the chat after this ends. And look, it's an exciting time. The past 18 years have had more renewables development in North America than any other point in history. We are, if you look at the statistics, we are at an inflection point here. And just, I agree, Dean, it does happen at the policy level. That is this is a top-down sector, and we need policies that create more supply across the board. Just thanks everyone for joining.
Yes, thank you very much. Amy, thank you very much for hosting us.
Oh, no. Well, thank you, Melissa, for moderating this evening. And thank you to all of our wonderful panelists for sharing your knowledge and your thoughts with us this evening. It was fascinating. So thank you. Special thanks to Gary Rosinski for putting this and all of our other panel discussions together, and to Lucia Dolan for being our tech person for each and every forum. If you enjoyed this conversation, please keep an eye out for more in the series in the future, and please get involved and get your friends and neighbors involved as well. Thank you, everyone, for coming this evening. We look forward to seeing you again at future climate crisis discussion panels. Stay tuned. This will send out a link to all the to everyone who joined us tonight with a YouTube video of this recording, and we hope that you'll share it with your friends. And please give us ideas on other future panels, because we'd love to host. So thank you and good night.